All right, this week we've been talking a lot about the atmospheric river that's going to be moving into California. And during these events, it can be a little bit scary because there's heavy rain, gusty winds, a large amount of snow, and that can lead to things like flooding, landslides, power outages, all sorts of impacts. But in the long run, atmospheric rivers are actually a crucial and beneficial part of the California ecosystem. It helps us out with the water supply, with the drought, with future wildfire danger. So it's a very nuanced topic. So I thought it would just be interesting to dive into the science behind what's actually happening so that we can better understand this concept that is incredibly important to California weather. So where atmospheric rivers start is actually at the sun. The sun is going to produce a large amount of radiation, and as we know, that's going to hit most directly near the equator. Now what's going to happen there is we are going to get evaporation. So that's going to take the ocean water, it's going to turn it into water vapor, and then that's going to be in the atmosphere. Now, if that was all that was needed for an atmospheric river, then we would have atmospheric rivers all the time. But as it turns out, you do also need some strong prevailing winds. So, where those winds come from is often from the jet stream. And if the jet stream is set up in a way that it's able to dip down into the tropics and then push up towards California, that's often when we're going to see that water vapor that was evaporated at the tropics funneling in to California. So, and then when that happens, as it's traveling up north, it's going to be cooling down, and as it cools down, it's going to condense, turn into clouds, and then there's actually something even more important that happens once it actually reaches California. So we're just going to come back over here, turn this on, and talk about what happens as that stream of water vapor pushes into California. So here's our stream of water vapor coming in, and it's going to bump into our coastal mountains. I'm using the Santa Cruz Mountains as our example right here. It can't just go through the mountains, so it's going to rise up like that. And as it does that, it's going to cool. Now what happens when it cools is colder air can't hold as much water vapor as warmer air, so some of that water vapor is going to condense into liquid water. So we're going to get clouds forming on the windward or usually westward sides of our mountains. Now what that's going to do is then lead to a massive amount of rain on this western edge. And especially in the higher elevations that are most impacted by what is called orographic uplift. That's a good word. Orographic uplift. All right. So you would think, oh, that's enough. Then all the rain is squeezed out and we're just going to have a little desert in the Central Valley. And sometimes that is the case. You usually see much less rain on the leeward sides of mountains. But these atmospheric rivers are bringing so much water vapor that there's still going to be some left over for the Sierra. And just to put it in context, a lot of times an atmospheric river will be transporting as much water vapor as 7 to 15 Mississippi rivers. How much flow we see along the Mississippi River in a day. So imagine 7 Mississippi rivers in the sky above you, bouncing into mountains, lifting up into clouds, and squeezing out water. That's why we can get so much rainfall with these events. So next, our water vapor is going to come along here. We'll just label this. Still some water vapor. And then it's going to bump into the Sierra, and it's going to lift up. Now the exact same thing is going to happen. We're going to see a large amount of cloud development on the western side of the Sierra, and this is going to lead to a massive amount of rainfall. Now, in some cases, we can also see a large amount of snow falling, especially on this western edge. But what's interesting about atmospheric rivers is you think about where they come from. It's coming from the tropics. As you know, the temperatures in the tropics are very warm. So you end up getting more rain than you would with a normal winter storm. So because of that, this can actually be bad for our snowpack sometimes, because the rain is able to fall on some of the snow that had previously fallen at lower elevations, and it's able to melt that snow and kind of just mess up our snowpack a little bit. So the basic gist there is atmospheric rivers are warmer because they're coming from the tropics, so your snow levels aren't going to be as low as your typical winter storm. But regardless, it's going to lead to a massive amount of water, and especially on the windward sides of our coastal mountain ranges and the Sierra. Now with that, you get so much water so fast that it's not able to penetrate into the soils, and especially if the soils are already saturated because there's already been atmospheric rivers before or just storms before, and that's where you get a large amount of flooding. And then it's also very windy conditions. So, and if you have saturated soils, it's easier for trees to come down. So then that's where you can have trees, branches coming down, that leads to damages, also leads to power outages. So that's the bad side of things. On the good side of things, it can lead to things like drought alleviation. We've seen that throughout the course of this last winter. Our drought is basically gone in California because we've had a few of these big events. It can help out with the water supply, and then it can also help out with wildfire. So might actually be a good idea just for me to label those real quick. So let's just look at cons first. That would be flooding. Things like landslides. And one more we'll put in power outages. All right, now we want to end this video on some good news. So let's go to pros. Biggest one that we've seen with our reservoirs is water supply. Also great help when it comes to drought alleviation. I'm not going to write out alleviation. And then future wildfires. Now there's a little debate there because some people say atmospheric rivers then allow water for more plants to grow, which can increase your area burn because there's more grasses. But overall, the biggest factor that leads to extreme wildfires is how dry the fuels are. So we will take the moisture when we can get it. So hopefully you learned a little bit more about atmospheric rivers throughout the course of this video. Let me know if you have any other questions, and thanks for watching.